Okay, so next up we will be looking at midpoint formula. Okay, so very important, guys. We're all working in analytical geometry and not Euclidean geometry. So often some of you confuse midpoint formula with midpoint theorem. Right, so remember, midpoint theorem is a Euclidean concept, whereas midpoint formula is an analytical concept. That doesn't mean that they'll be so strict in separating the two and not ask any Euclidean in analytical. They won't ask analytical in Euclidean, very rarely. But just do try and keep those separate in your minds, right? Midpoint formula we use when we need to find out what are the coordinates at the midpoint or the middle between two other coordinates, right? Or if we're given a line segment, what are the coordinates of the midpoint of that line segment, right? Whereas midpoint theorem tells us that when a line cuts the midpoints of two sides of a triangle, then automatically it will be parallel to the third side and half the length of the third side, right? Euclidean, analytical. Okay, so midpoint formula, what does it look like? If we are given a line segment, right, and we have those two extreme points of the line segment, let's switch it up. Let's call it M and N. Oh no, let's not call it M because midpoint's M. Let's call it like D and F. Okay, so we have coordinates D, X, Y, and let's make that 1 and 1, and we have coordinates of F, which is X2 and Y2, right? How midpoint formula works is that with midpoint formula, we can find the coordinates of M, the midpoint of DF, right? So that'll obviously be my midpoints XY. Okay, right, so midpoint formula, what it looks like, capital M, right, because we know small m is gradients, which we'll get into in the next video. Capital M, open bracket, right? So midpoint formula already comes in coordinate form, so it's not really necessary to put an equal to sign because it comes in coordinate form already. So if you think about just a normal ruler, let's say a ruler is 30 centimeters, right? And I ask you, what is the halfway point of that ruler? You're going to tell me 15. How did you find that? All you did was half that 30. So we do the exact same thing with coordinates, right? We are just going to find the middle and half it, or divide by 2. So I'm going to say my one extreme point, x1, plus my other extreme point, x, x2, over 2 to find my midpoints x. To find my midpoints y, same thing. I will say y1 plus y2 divided by 2. And that is midpoint formula. Right, so pretty easy. If I need to find the midpoint of a line, I'll just substitute in my points and divide by 2. Very important though is that midpoint formula helps me find the midpoints coordinates. So what happens when they give me my midpoints coordinates and I need to use that to find one of my extreme points? I'll do an example of that now. Right, let us say, where's it is? Boom. Let us say that they've given us a line segment and they tell me that that is B and that is C. They tell me B is -4 and, oh no, let's make it 0. That's interesting. My midpoint of that line is -2 and 3. And they say that C is X and Y. But we're given the information that M is the midpoint of line BC, right? So knowing that M is the midpoint of line BC, we know that we can apply midpoint formula. So we'll start like that. We'll say my midpoint is equal to x1 plus x2 all over 2, y1 plus y2 all over 2, right? Formula is very important. Plug them in. They're for marks, you know, free marks, guys. So we know that my midpoint, obviously this formula is to find my midpoint's coordinates, but I already have my midpoint's coordinates. So how do we use it to find one of my extreme points? All you do is you separate it and make up your own equations. So we know that this is used to find my midpoints x. So I will say midpoints x is equal to x1 plus x2 over 2. And I know then my midpoints y is equal to y1 plus y2 over 2. So all you do is then you sub in the necessary from the information that you have, and then you will find the answer. As easy as that. My midpoints x is -2, x1 I'll let be b, -4, plus x2 we're looking for, that's c's x, all over 2. Solve for c's x. First thing I'll do is times both sides by 2, that gives me -4 is equal to -4 plus c's x. Take my -4 over, it becomes positive, so c's x is going to be 0. Wow, look how that worked out. Okay, midpoints y, my midpoints y is +3. So I'll say +3 equals to my y1, 0 from b, plus c's y equals to 2. Times both sides by 2, 6 is equal to 0 plus cy. So therefore c's y is just equal to 6. Have c's x, have c's y. Always just remember, answer the question. If they're asking what is the coordinates of c, don't leave it here. Write it in coordinate form. So c's coordinate will be 0 and 6. Right? Easy. Something just to note with midpoint formula that often, because remember with analytical it's important to know when to apply what. Right? So if they ever mention median, we know from statistics that median, or the median value in a data set, obviously is that middle value once it's ordered. So middle, midpoint, you see the same type of wording. So if ever they refer to a median, know that a median, especially when it comes to triangles, right, is if I say in triangle ABC that BD is a median, right, especially to AC, that means that from this vertex B, right, a line is drawn somewhere to the midpoint of AC, right, that splits AC in half. So point D will split AC in half. Right, so it's very important to note that this line BD only splits AC in half. It is not necessarily 90 degrees. Okay, that is what we'll call an altitude, which we'll get into when we touch on gradients. But BD is a median. That means then, or let's say they say at D, right, or from AC, then we know then that D is the midpoint of line AC. So if ever they say something like this, maybe they give you A and C coordinates, and they say determine the coordinates of D. If BD is a median, then we'll know midpoint formula. Other than that, stay tuned for the next video on straight lines and gradients.